Hi, Assalamualaikum warahmatullahi wabarakatuh. This is video group assignment 1 Skee 1073 section 01 electronic device and circuit for group 1, which is our team member is MAURICE, FAUZAN and me, DANISH. First and foremost, before we go to the circuit simulation by TINKERCAD, I will explain briefly about the concept of AC-DC power supply. AC-DC power supply convert alternating current, which is AC voltage, into the steady direct current, DC voltage, that the most of the device need to operate. First step is rectification, to convert the AC voltage into one direction flow, and this time we will use a diode center tap type rectifier. Second step is filtering. We use the capacitor to smooth out this pulse, reducing the ripple. And last but not least is regulator, to maintain and ensure a stable DC voltage. For rectifier, usually we will use a full wave rectifier, since it can rectify 360 degree of the input with the output and average value and frequency twice of the output half wave rectifier. As we use center tap type rectifier, I will explain briefly how the mechanism is worked. The center tap type rectifier only use 2 diodes and not 4 diodes like the bridge type rectifier. We can see here the secondary winding of the center tap during the positive half cycle of the AC voltage. The diode 1 is in forward bias, while diode 2 is in reverse bias. So the current will flow through the diode 1 and then into the load, and lastly return to transformer through the center tap connection. Here the most interesting part is our AC-DC full wave center tap type rectifier power supply circuit configuration by using TINKERCAD. First and foremost, we will need 2 power supplies basically. We will use 2 function generator. Why 2? Because TINKERCAD doesn't have a center tap transformer component, so we will use these 2 function generator to simulate the 2 out of the phase output of the center tap transformer secondary coil. This is very essential for our full wave rectifier. The value we will use is frequency 100 Hz, amplitude 10 volt with a sine function. Next, we will need a 2 diode for our rectifier, 1 capacitor with a value 20 microfarad for filtering, and then we will need a 3 resistor, which one is our load resistor with a value 5 kilo ohms, while the another 2 resistor as a series resistor with a value of 1 kilo ohm for our Zener diode. And for Zener diode, we will use a Zener voltage of 2.5 volt for regulation. And last but not least, these 3 oscilloscope and multimeter to display the current value. Oscilloscope 1 to show our AC voltage. Oscilloscope 2 will show the pulsating DC after rectification. And then oscilloscope 3 will show the filtered DC across our load, which the regulated one. Next is simulation part. I also will explain the flow of it. Firstly, from the multimeter and oscilloscope, we can observe the input from the power source. We will see it is in alternating current AC voltage. Look, positive, negative, and then from this power source during the positive half cycle of the voltage on the transformer secondary winding, the current will flow through this diode 1. This is because at that moment diode 1 is in forward bias, while diode 2 is in reverse bias. So hardly any current will flow through the diode 2, and it mainly goes through diode 1. This is what we call rectification, turning AC into the DC voltage. Then, this rectified current will split. Some current will flow to the capacitor, which store energy and help to smooth out the voltage, making it less bumpy, while the other part of the current flow through the load resistor, which is how the power get to what we are trying to run. For this part, we call it filtering. And then, this filter voltage reach what we call regulator part. This often involve a component like Zener diode with a series resistor before it and a Zener itself connected in parallel with our load resistor. Here where some magic happen. The Zener diode work to regulate, maintain and ensure a stable DC output voltage, even if the input voltage from the filter change a bit or the load try to draw more or less current. This is what we call regulator part. And last but not least, the output current from the regulator section will flow to the load, and this cycle will keep repeating, either it in positive half cycle or negative half cycle. In conclusion, the circuit nicely confirmed our theoretical understanding, as we saw the signal on our first oscilloscope clearly display an AC voltage signal. Then on second oscilloscope, we observe it transform into the DC voltage. And finally, at the output stage, after all the filtering and regulation, it becomes the smooth, stable DC voltage signal, the one we want. That's all from our group. Group 1, thank you.